Okay, so there's lots of forces in motion. I'm going to split this into 2 bits. First bit, I'm going to do the acceleration, the speed and motion graphs. So first one there, an object accelerates from 4 meters per second. So that's going to be the initial u, 222, so that's v, the final velocity, and it tells me an acceleration. It wants the distance. Okay, so that's definitely the one that's got x in it. So it's then get our equation, v squared minus u squared equals 2ax. Let's just move that u and v a little bit further down. And we want to get x on its own, so that 2a needs to go underneath. So rearrange it and we get a mark for that. Then calculate it. So the final velocity is 22 squared, remember to square it, minus 4 squared divided by 2 lots of the acceleration. So that gives us 468 divided by 3 is 156, and remember our unit meters. Use the graph to determine how far Colin had travelled after 500 seconds. So here's the seconds, there's the 500. Read up. We can then read across and we can see that's 500. And I'll just delete all of that. So he went 500 meters. Next one, it says calculate his instantaneous speed for section A. So there's section A. If I just put a red line around it, and we know speed equals distance divided by time. So we're going to need our shoot Donald Trump. And now I can find the distance on this part here. So that's 500. Time is here, 400. And we're away. So if I just go, we know that the distance is 500 and the time is 400. So 1 mark, speed equals distance divided by time, 500, the distance, divided by the time, 400 equals 1.25, and the unit, meters per second. But the next one's really tricky. I'm just going to delete all of this. And that's your bell going off to say that your break is done. It says AMDIP moves at a constant speed, says S, of 1.5 meters per second. What's the time difference between him and Colin to meet 750 meters per second? So we're going to need our shoot, Donald Trump, and it says what is the time? So T equals D over S. There's my distance, 750, divided by 1.5, and we know that AMDIP took 500 seconds. Well, for Colin, we've got to use the graph. So we're now going to go and find where he was at 750 meters. And we can see 750 meters is there. So we're going to go across, read down, and we can see that's 680 meters because each of these are units of 20. So now that I know he took 680 seconds, because it's a time, not how far. So we know Colin was 680 seconds. We know that AMDIP was 500 seconds. We just then take those away to get the difference. Next question, describe the journey of a vehicle. We've got to put it by the side of the graph there. And we can see, always check that. So this is a velocity time graph. And our answer is between 0 and 2. And it's always a good idea to say what you're moving between. So between 0 and 2, it's accelerating at a constant rate. That's that bit done. This part now, we can see straight lines. So they're moving at a constant speed. So it's a constant velocity of 30 meters per second. And then C, we've got an acceleration again. And it's acceleration at a constant rate. You see, I've just chunked it in terms of 6 to 8. My bum, that should be 5. Oh, sorry, guys. So 5 to 8 there. It says use the graph to calculate the acceleration between 5 and 8 seconds. So if I rubber up all of that, we know draw a triangle. That's it there. And we know it's always going to be y divided by x for these. So we can see that change there is 20. It's gone from 50 to 30. Here we've gone from 5 to 8. That's a change of 3. And I've just got to do 20 over 3. So the full equation you could use in the exam y over x, and I'd have to give you the marks. So a equals v minus u over t. So final velocity was 50. It started at 30. Take those away. 20 divided by 3 equals 6.6 recurring. I've rounded up to 1 decimal place. Please make sure you know that unit really well. It's going to come up a lot. Okay, next part. We've got to work out the distance between 0 and 5 seconds. So I'm just going to draw down and there. And I've split it up into shape A and B. So I've got a triangle, and that's always going to be x times y over 2. and then I've got a rectangle, or probably it looks like a square to me, but we know that's XY. So as long as we know the little change, the differences here, all right, those changes will be in. So the first part, section A, I'm going to rub this all off now. So we've got the change here is 30. That's where that came from. Oh, I've just deleted it. And then I've got to multiply it by 2 and then divide by 2 because it's a triangle. I don't want the full shape. I don't want this bit. All right. So I know it's gone 30 meters here. Now let's go and do shape B. Now again, I'll get rid of all my working, but I'll just keep the idea that we know that that bit's 30 meters. So now let's look at B, and we've got the change. It's gone from 2 to 5, that's a change of 3. 0 to 30, that's a change of 30. And we'll just multiply those together. So 30 times 3 equals 90, and the last part, add that all together. Okay, next one. We're going to need our A, V minus U, and T. The car's got an average acceleration, so I'm just going to write an A there, of 0.8 meters per second squared. The car starts at 5 meters per second. How long does it take the car to reach 21? So to reach is the final, so that's 21 minus 5, and we want to find T. So we can now see what's going on here. T equals V minus U over A. So if I just rub that out, write it a little bit neater underneath. So A, V minus U over T, and you can see what's happening. So final speed 21, it's going in there. It started at 5, that's going on there. Take those two away, 16. And my acceleration goes underneath 20 seconds. And I'm going to stop there. That's the first section, so you can see that covers quite a lot, and that there's a lot of forces and motion on there. I should stop it.